This is the Further Pure Maths January 2022 paper 2 from Pearson Edexcel IGCSE. Let's just do it. So the area of our sector is r squared theta over 2 if you're working in radians. So we just do 7 squared times 1.2 divided by 2 and we get this answer. The arc length of a sector in radians is simply r theta. So it's just going to be 7 times 1.2 is this length here. Of course, the perimeter will just be add 7, and we'll have a very easy warm-up question that we get done with. Next question, then question 2. So what we can do is you can move this thing over to the other side to get this. And now sine divided by cos is tan. And that works regardless what angle is in here. So sine of this over cos of this is just tan of this thing here. So divide both sides by cos, you get this. Of course, tan inverse both sides here. And your first calculator solution will be 60. We're working degrees again here. And but of course tan is repetitive every 180, so let's go to the next one. So 60 plus 180 is 240. Now that's out of the bounds here, but when we add 20 and divide by 2, it will actually fall within them. So you might want to be safer just doing the next one as well, or even the one before it. But actually these are the only two that are going to work. But tan is just repetitive every 180. You can draw the graph if you want to, or just keep adding and subtracting 180 for that one. Cos and sine work slightly differently. I would suggest drawing the graph for them. But anyway, here we just add 20 and divide by 2, and we end up with our two solutions. For question number 3, then, this curve is this. So let's draw it. It's a quadratic with y-intercept of 9, and it's upside down, so it's going to look like this. It's symmetrical because there's no x term. And the roots here, well, when this equals 0, we just clearly have x is plus or minus 3. So the area we're going to look for is this area here, which is bounded by 3 and minus 3, so this integral here. I'm going to be a bit more lazy here and just say that I can just integrate this between 0 and 3 and double the answer, because I'm just going to find this area and then double it. Like I said, the graph is symmetrical. The reason I'm doing this is because when I integrate this for 9x minus x cubed over 3, putting in this limit of 0 is going to be super easy because it just all goes away. So I only have one actual job to do here. The second half just is a 0 here. Anyway, this is 27. This is 27 over 3, which is 9, which makes 18, and then times it by 2. And we end up with 36. Question 4 is probably the most interesting one on the paper. We'll start here, you can ignore this for just a second. If I hadn't have pointed out that, no one would have noticed it anyway. But anyway, find the length of f to c. So FC is all the way along here. We can just maybe call this length 10 here, because clearly it is. And then we can just do triple Pythagoras and say 10 squared plus 10 squared plus 10 squared. Square rooted is FC, and we'll end up with 10 root 3. And then find the size of FCA, so draw a straight line from A to C. And then we want this angle, that's clearly, well this length here is 10 squared plus 10 squared square rooted, which is 10 root 2. You can put that on a calculator if you want to. And then this angle is going to be, or opposite is here, adjacent is here, it's right angled. So tan inverse of 10 over 10 root 2. And we'll get this in degrees, which I presume it wants. Oh yeah, it doesn't want degrees, there it is. And the next part is weird. So plane BFH is like a plane that goes through the shape and cuts this kind of triangular pyramid shape out of it. And then the plane BHC is the side of the shape itself. And it wants the size of the obtuse angle between those two things. What I did was I thought I would just bring this up here, just to show you exactly what I was talking about. So there's the plane, this red thing here is the plane connecting the three corners that we said before. And then we're also interested in the plane of just this side of the cube. So what's the angle that they meet at? Well, if we look kind of underneath it, we might be able to see it a bit more clearly. What they're looking for, obtuse angle bigger than 90. They're looking for the angle between kind of this straight edge and the plane here. So they're looking for kind of this angle measured around here, inside that shape there. That's what they're looking for. So how do we go about finding that? Well, what we can do is we can just draw a line straight to the midpoint of this line here from the corner, and then another line from the midpoint up to this corner. And that will give us two things that we can use. And then kind of, if you imagine those two lines here and here, we can get the angle between them. The reason is we can just do one more line there. And I think at this point, it might be more clear to go back to my actual work, which is here. And I'll show you what I mean. So let's get this midpoint of those two things here. And then let's also get up to there. And then the final thing we need to do is go from F to C all the way down there, because then we can create this triangle. I've called this point M just because it's the midpoint of these. And I think all I need is this angle here, right? We decided, looking at that cube in 3D, I want this angle around here, which when you just draw this triangle out flat, F to C is just the diagonal of the entire cube. We end up with this, and we want to be looking at this angle. And I think we can do that if we just find a bunch of lengths. We already know f to c is the same as, well, we got it there, right? It was 10 root 3. I think it was, yeah, 10 root 3 makes sense. So let's just find the other two lengths. Well, this length here is clearly, it's just half of g to c, right? Which is just 10 squared plus 10 squared root, which is 10 root 2. So I think this is just 10 root 2 divided by 2, because it's clearly just going to be in the middle of this square on the side. And what about this one here? Well, there's a couple of ways you could do f to m, sorry, here, for this length. What I decided to do was say this is 10 root 2, and so is, that's, by the way, half is 5 root 2. This is 5 root 2, as we just decided. It's just all 5 root 2's into the corner, into the middle of this square here is just all 5 root 2's. And of course, this squared minus this squared will get this length squared, because we can see there's a right angled triangle kind of within this shape here, from f to this x to b to f again. So this squared minus this squared will get you this, I think, because that's squared is 100 times 2 is 200. That's 25 times 2 is 50. Take them away, and then root 150. So that's going to be root 150. And then we can just use cosine rule to find theta. So square all these things. You've got calculators. Just add these all up and then divide, and you get this, and then do cos inverse to the nearest degree. Is that there? I thought that was probably the hardest question on here. Find the values of t when it's at rest. Well, at rest means v is 0, so we just put v as 0 in there. This factorizes. If you look hard enough, you could just use quadratic formula. You get these two values of t. The acceleration is dv by dt. So acceleration is just this differentiated. So that's 6t minus 23. So always remember acceleration is dv by dt. Find the range of values for which the acceleration is greater than 0. So we just want this to be greater than 0. So we just solve that. It should be nice and quick. And then the displacement. So when it starts talking about distance away from things, so we're talking about coordinates. So we're clearly talking about the distance away from the origin. We're going to do the integral of velocity. So this displacement is the integral of velocity. So let's integrate all of this. I'll call the displacement s, just like you would in a SUVAC question if you've done those. So integrate this thing. Remember the plus c. When t is 0, our displacement from the origin is just d, because we don't have any y displacement. We're just d away horizontally. So we'll substitute that in, and we'll find d is c, which I guess I could have just written immediately, but whatever. And then when t is 8, so putting in 8s in here, we get s is 26. And we sub that in, and we get d is this, which gives you this. And we have the value of d is 10, which will be good for this question. This is a really interesting one, I thought. Find the value of s20. We'll just put 20s in here, and you get 2 free marks. Sometimes this paper just throws you absolute free marks, and it's really weird, because then it gives you some really hard stuff to do. But anyway, given that s of n is this thing here, so okay, what's going on here? Let's break this sum down a little bit. I was tempted to break out this as well, but I don't think we need it right away. When r is 1, we just have a plus b, and then when r is 2, we have 2a plus b, and then when r is 3, we have 3s plus b, all the way up to when r is n, when we have na plus b, or an plus b, it doesn't really matter. So this is a sum, and essentially what we're saying here is I've got a sequence that just goes this, then this, then this, then this, all the way to this, and the sum is just what happens when we add them up. So the first term of the sequence is a plus b, and the second term is 2a plus b, and so on. And I think that's really helpful, because what I can say then is I could say that a plus b is the first term, and the difference is also a, right? Because we go from, the b's just are the same, so we go from a to 2a, let's sort of just add a, and add a again. So I know the difference of this series is a, and I know the sum is a plus b, sorry, the first term is a plus b, which is going to come helpful later. But right now, I think the easiest way of doing this is just to say, well, the sum of one term is just 5. And what happens when you sum one term? Well, you're just looking at the first term. So I think I now have that a plus b is 5. The first term is just 5, because that's the sum of all of the terms up to the first term. It's just the first term. And of course, the sum of the first two terms, I can just put 2 in here, and I'll get this. That's just putting 2 in here. But the sum of the first two terms is this plus this. So that's 3a plus 2b, and that must be 14. And now I can just double this for 2a plus 2b is 10, take this away from this, you get a is 4, and then you get b is 1. And so the first term is 5, and the difference is 4. And that will be helpful later, I think, maybe. Anyway, a different arithmetic series has first term 7 and common difference 4. So we can now use this. So the sum of the first tn terms of that is n over 2 into 2 times 7 plus n minus 1 times 4. And that's equal to the sum of the first n terms of s, which is given by this. I could use this formula again, but it would be more difficult. So I'll use the formula they've given me up here for that, plus 252. And now, of course, I can just deal with this, right? So I can divide these two things by 2 times everything by n through this. This is just algebra. These things cancel, which is very kind of them. This doesn't seem right, does it? Oh, that's 5. Yeah, that's perfect. We get this here. And I think that'll be the answer. So yeah, kind of an interesting question. But yeah. Okay, f of x has roots alpha and beta. That means that alpha plus beta is minus p over 2. And alpha beta is q over 2. This is a minus because you're summing these two things individually. This is not because you're multiplying there. You should probably have just known that rule, I guess. There are lots of good YouTube videos that explain exactly why that is. But anyway. And then for this one here, this plus this, again, will be minus this over this. And then this times this will be this over this, which cancels for 1 equals 1. So yeah, that doesn't turn out to be very helpful anyway. Given this, let's solve for P and Q. So, okay, we've got quite a bit of stuff to do here, but let's go through it then. So I think we can combine these things together. So times this by alpha over alpha and this by beta over beta. And then we can put these two terms together because you've got the same denominator. But I think looking at this one, if we square both sides here, we get alpha plus beta all squared equals p squared over 4. The negative obviously cancels with itself, so that's good. Expand this out, and we get this, and then 2a alpha beta is just q. And then we can take q away from both sides, and we end up with this. That's perfect. Let's put that thing into there, and let's put this thing into there. Dividing by a half is the same as timesing by 2, so let's bring that all the way to the top to times this by 2. Bring that q over there as well, and I think we end up with this, which is making progress. I think I times everything by 14 here, and then I added this to both sides. I thought I'd made a mistake here because this is definitely positive and this is a negative, except if q is negative, this is also positive. So this is actually fine. And then we have this information as well here, right? So let's rearrange this for q, is what I did. You can do lots of things from here, and sub it into there. Expand out, rearrange. This also factorizes. If you look hard enough, quadratic formula would have got you it anyway. P is a integer, and so is q, which means p is 3 is the answer. And therefore q, looking at this, is minus 7, or you can use this one down here. It doesn't matter. But we've got that done. Given alpha is greater than beta, show this thing here. So these are the results that we had before, except I'm using p as 3 and q as minus 7 now to get them into this. I think what I can say is this factorizes to this. Always use that result if you can. Always use it. We already have this result. That's there. So I just need this here. A little bit of clever trickery gets me that, I think. Let's take this one here and take away 2 alpha beta from both sides. Because that way, this thing here factorizes to alpha minus beta all squared. And this over here is just 2 lots of this, which is minus 7. And then minus 7 is plus 7, so that makes it plus 14 there. Now I can square root both. First, I think I should put those two things together. Now I can square root both sides. Alpha is bigger than beta, so therefore this is a positive number, so therefore this is a positive number. And I can substitute that into there, and I can substitute this into there. And I think I end up with exactly what they wanted me to get for that result there. Excellent. So I'm going to skip over this, obviously, because, yep. And then we're going to plot all the points, which I'm also going to skip over because we all attended year 7 maths. So cool. Can we take a moment to appreciate what an incredible curve that is? What a job. Then we've got this to do. The formula book talks about this. Cos of 2a is clearly cos of a plus a, because a plus a is 2a. Again, we all went to year 7 maths. And then cos of a plus a, according to this rule, is cos of a minus sine of a sine of a. Of course, cos of a is cos squared of a, and likewise here, cos squared of a is 1 minus sine squared a. And then, of course, we can collect those together and we'll end up with our result. F of x is this thing, which is interesting. It looks quite similar to this thing, but not quite. I mean, the first thing we should do, if they've told us to do that, we should replace that result in there, I think. That should be the obvious thing to try and do. You end up with this. And now when you're doing questions like this, so they're asking us to do f of x equals 0, so we'll get this thing here equals 0. When you're doing questions like this, and you've already sketched a similar-ish result, just try and force the result that you've sketched into this algebra. So for example, right here I have 6 sine squareds, and here I have 12. So the first thing I'm going to do to all of this is just halve it all. This works out brilliantly because it gives me a sine of x, it gives me a 6 sine squared of x. This bit's not quite right, so what I'll do is I'll take away 1 from both sides to make this match, and I'll also add this into both sides to make this go away, and therefore I now have this result written here. And so what this last line is saying is where does the line y equals this intersect the curve y equals this, right? Because if you were answering that question, you just set them equal to each other, you'd get this, then you'd work up, and you would end up here. But instead of doing that, I can just sketch this line here, because I've already sketched this curve. Just sketch this line here, gradient to half. Well, just be careful with the um, scale, but you've got 1 here and 2 here, so that's gradient to half. 1 to minus 1, there it is, and it looks like it's a 0.6 and 2.4, 2.3, something like that. And we'll have our answer done. We've only got a couple of questions left. Always a good vector question to do here. I've got a video all about these kind of vector questions, so if you want to watch it, you can do. A to B is clearly minus 2a plus 4b, nice and easy. Not sure what the 2 marks are for there. O to P, now P is the midpoint of AB. So if A to B is minus 2a plus 4b, A to P is minus a plus 2b, just going to be half of it. And therefore O to P is 2a plus this. Of course, 2a minus a is just a plus 2b, and we end up with O to P. Q is on O to P such that we have a ratio 3 here, 1 here. So that's Q. Find A to Q. Well, O to Q is just going to be 3/4 of O to P, because you've got 3 parts here, 1 part there. That's 4 parts in total, and 3 of them are here. So O to Q is 3/4 of this. And so therefore A to Q is minus 2a plus 3/4 of that. And of course we can simplify that, and we'll end up with this here as our A to Q. R lies on O to B, such that AQR is a straight line, so R is down there somewhere. So what we can immediately say here is that A to R is some k lots of A to Q, where k is just a number bigger than 1. Because this is a straight line, I can just times this vector by some number bigger than 1, and I'll turn it into the vector A to R. And that's really important because it gives me the result that O to R could be written as 2a plus, like I just said, k lots of A to Q, plus a big multiple of A to Q, which I just have there. So that's O to R. I can rewrite this in terms of A only to get this. And then finally, what I can say is O to R is also just some multiple of 4b, because, and that multiple is less than 1, right? It's just some amount of O to B, which is 4b. But comparing these two things, they describe the same vector, right? So comparing these two things, this thing here must be 0, because I know O to R only is parallel to 4b, right? So there are no a's here. So this must be 0, so I can just set this to 0, and there are no a's here, so that's why I can just compare these. Maybe it's the other way of thinking about it. And 4m, the amount of b's here, must be equal to the amount of b's up here. So we end up with this. Of course, this is solvable. You get this, and then this is also solvable once you substitute in k, and you end up with this. And so if m is 3/5, that's the thing that I used here. So 3/5 of O to B is this bit. That means there's ratio 3 here, 2 here. So it's ratio 3 to 2. And we'll have our answer. Final question then is a nice one. We've got 2 asymptotes here. Now, one asymptote is essentially you can just do this number divided by this number, 2 over 1. Because what you can say is if y was 2 and you cross multiplied, you get 2x plus 8 equals 2x minus 1. The 2x's will cancel and you get plus 8 equals minus 1, which never works. So y equals 2 is an asymptote. So that's cool. That'll be the first one. And the second asymptote will clearly be at x equals minus 4. It's actually pretty much just told you that one must exist there. At this point, we know that this curve, it looks a bit like the curve 1 over x. It exists in 2 of these 4 quadrants as kind of C-shaped curves. And now which 2 quadrants exist in? Well, they're definitely the opposite 2. So it's either this one, or this one, and this one. Just test one of the points somewhere. So if x is 0, for instance, you get minus 1 over 4, and y is minus 1/4, so that's this point roughly here. And so the curve must go this way, and then this way up here, and we'll end up with that. Now, it didn't actually ask me to do that first, I've just noticed. It said, find the coordinates of the intersection. So I actually just did that, 0 minus 1/4. For this one here, we need to say, what happens when y is 0? Of course, cross multiply, this goes away, so we just end up with that as 0, so x is a half. So this is the point 1/2, 0. I already said this is the point 0 minus 1/4. And I think that's all I need to do there. And yeah, I think that's all of those marks. The line y equals x plus k1 is tangent to C at P. And then there's another line with same gradient, so parallel, that's also tangent. So I think it looks a bit like this, right? Where you've got a point here and a point here. That should really intersect, but it pretty much almost does. With points P and Q. Now P is this one because the x coordinate of P, which is positive in this case, is bigger than the x coordinate here. So I think this is P and Q here, roughly. Using calculus, find the coordinates. Now, we know the gradient of these lines here is just 1. So therefore, we need the gradient of the curves to also be 1, because, of course, they're tangent to each other. So let's just find dy by dx of this. I'll refuse to do quotient rule as normal, and I'll just do product rule with a power -1. So differentiate this for a 2, leave this alone, and then differentiate this for a -1, lots of this, break that down to a -2. Differential of that is just 1, so it just doesn't matter. Set that equal to 1, because remember we need the gradient to be 1 to match these guys. Times everything by x plus 4 all squared to get rid of this, to introduce 1 here and introduce 2 of them there. Expand everything out, collect everything together. That kind of expands out quite nicely. Factorize, and we get solutions of -1 and -7. So P has x coordinate 1. Sorry, -1. So the picture is a bit off, but that's okay. It doesn't matter. And Q has x coordinate -7. And then we can just shove those x coordinates into here. -1 times 2 is -2, -3 over +3 makes -1 there, I think. And then -7 is -14, -15 over -3, it looks like. So a +5, I think, will go there. And that's all of that done. Hence, find the value of k1 and k2. So we know these coordinates now. So we can just say, for p, that went through this line here, which was the one for this one. So that's k1, because it was the one for p. So let's just substitute in -7 and 5 into here. Sorry, -1 and -1 into here, because that's the one for p. And we'll find k1 is clearly 0. And then let's substitute -7 and 5 into here, and we'll find k2 is that. That's the whole paper. Thanks for watching. I'll see you next time.